Intersections, part 3. Here's a couple of problems we're going to consider. Suppose we have a line, x equals t plus 2, y equals 2t, z equals 3t. Does this intersect the xy plane? And if so, where? Or xz plane, sorry about that. Well, let me draw you a very simple picture. Here is x, y, z. The xz plane is right here. And what condition is true? Well, guess what? Y equals 0. Anywhere in the xz plane, y equals 0, and anywhere y equals 0, we're in the xz plane. So we can just plug in 0 here. 0 equals 2t, and that gives us t equals 0. We can substitute back. X equals 0 plus 2, or 2. Y is 2 times 0, or 0. And z equals 3 times 0, or 0. So it turns out x equals 2 right here. There's the point where it intersects. Now here's a second problem. Let's take the same line. Does it intersect the z-axis? Well, we can see it probably doesn't intersect the z-axis based on this problem. Let's suppose we don't know that. Here's z, here's x, here's y. Any point on the z-axis, if you pick a point, like for instance, that 0, 0, 3, x and y have to be simultaneously 0. Both of them have to be. So you can set 0 equals t plus 2. 0 equals 2t, and you have to have one solution, the same time value. Well, guess what? This gives you t equals negative 2. This gives you t equals 0. Well, t can't simultaneously be 0 and negative 2. So these two values say no, it does not. If we wanted to ask, does it intersect the x-axis? Interesting question. Here, visually, we know it does. But what's true on the x-axis? Right here at x equals 2, that's the point 2, 0, 0. And what happens is y and z have to simultaneously be 0. So let's work that out, see how the algebra plays out. Let's change this to x-axis. We have to have y equals z equals 0. So you can plug in here, 0 equals 2t. Plug in 0 here, 0 equals 3t. And guess what? We get t equals 0, t equals 0. We get the same value. T equals 0 makes both of these 0. So the answer is yes. You can plug t equals 0 in here, x equals 0 plus 2, or 2. And sure enough, we found this same point. Okay, that's all there is to intersections, part 3.